It's arrived! Oh my gosh, I was so excited when it got here that I kind of already popped open the package. But don't worry, I didn't get too deep because I wanted to open it together with you. I mean, it's always fun getting something new, right? But this is different because we created this, we designed it and built it, sent it off for manufacture. So it's not just like another new toy. This is something that we made. Oh, look at this. Pop this open here. This is so nice. What do we got? Look at that. Nicely sealed up. There's our control board. What else we got in the box? And there they are, our drivers. Let's pop these open. Sweet. This is our controller board. Through-hole design, two-sided. So far, so good. It's got all the printing on it that we asked for. So it's packaged up and nice. Oh, look. There's a place to tear it open. Beautiful. Designing these custom printed circuit boards was such an adventure. And the fact that we made these and they are now in my hands physically, the feeling is amazing. Now, all that remains to be seen is whether they actually work as designed. That's what we're going to find out today. Stick around, we'll see if they work. We're on episode 23 of our journey today. If you're interested to understand how we designed these circuits and built those custom printed circuit boards, go back and watch some of the previous episodes. I'll put a link of our journey, which is a playlist, in the description below. Now, if you've managed to watch some of the previous episodes and you're here and you haven't yet subscribed, please do so. And if you like the videos, go ahead and let me know that you like them by hitting that like button. Today, we're going to be building, we're going to be soldering, and I'm so excited to get started. So here's all the parts that we're going to need for our build today. On the left, we have all the components for the indicator portion. In the middle, we have the up-down button components. Remember, when we designed our circuit, we designed two different methods of interfaces. We had one which had buttons to control the intensity of the high-power LEDs. We also have a rotary dial to control the intensity of the high-power LEDs. Today, we're just going to be implementing the button method. On the right, we have all the logic that includes the counters and all the logic gates. And on the bottom, we have all the components for our drivers. So let's go ahead and put all of those components onto these boards and see what happens. They're all built. Now, before I connect the driver to the controller, let's give it a quick test to make sure that it's working the way we expect. So I think the simplest test that we can do right now is if I flip this board around and give it some power, when I push the bottom button, this light should turn on. If I push the top button, this light should turn on. This, of course, is the reset button. But these lights should start off, ideally, with this LED on and the rest off. And as I push the up button, this indicator should rise. And if I push the down button, the indicator should fall. Let's give it a try, see what happens. It doesn't look good. These lights should not be on. In fact, the bottom light is completely off. So I think I know what went wrong here. So that might be an easy fix. Let's see if the buttons work. All right, so if I push the down button, I should see that light turn on. That works. Okay, so this is good. Now if I push the up button, the up light should turn on, and that dark LED should start moving up. Okay, so the up light is turning on, but the LED is not moving up. We got a problem. I finally figured it out. Troubleshooting electronic circuits always takes too long and inevitably always comes down to some simple error. And in this case, it was my own laziness. Check it out. My problem was right here with these two resistors that are part of the clock generation from the up-down button circuit. So I have a 15K and a 51K. And when I was putting this together, I thought, well, I got lots of 10Ks and 20Ks, not too many 15Ks and 51Ks. So I adjusted this a little bit. I changed the circuit to this. I used a 10K resistor here and two 20K resistors in series. And that gives us a 10 to 40 ratio. And that ratio is critical for clock pulse timing. Yet I never updated the schematic. I left it like this without the change of the resistor values. And so when it came time to create this, I was staring at this schematic and I had to kind of guess which resistors go where. And naturally, I screwed it up. This portion is like the heartbeat of our entire circuit. And if the heartbeat goes wrong, nothing works. Once I fix that, take a look. So here's our revised board. The two resistors I replaced are right over here. You can kind of see them sticking far out of the board. I had a hard time replacing those. So let's power it up, and you'll see, first of all, when I power it up, our lights turn on like they did before. By the way, the reason the one that should be on is off and the one that should be off are on is because I actually misread my instructions. So another bit of laziness on my part. To fix that, it's quite easy though. All I really needed to do is reverse the polarity of all of these LEDs, and on the other side of the board, change that resistor one slot down. Now, changing the resistor was easy. I didn't want to do it because I didn't want to desolder all of these LEDs. But in terms of the up and down button, so push the up, works, and you can see the non-lit LED go up, and if I push the down, works as expected. Push the up again, it works. My reset button works as well. Sorry, the power connection is not tight, so that's why it keeps turning on and off, but it's working as expected. But there's one other issue that I also discovered when I was doing this. If I push up, watch what happens. The LED here should stop when it reaches the top, but it keeps going. It actually goes through 2 cycles. And if I push down, well, let me get it right to the top again. If I push down 2 cycles, it goes through 2 cycles as well. So what the heck is going on there? Remember, when we put this circuit together, we gave the circuit a choice to use either 4-bit intensity, which would give us, or 16 different levels of intensity, 5-bit, which would give us 32, and a 6-bit, which would give us 64. Now, when I wired this up, you may have noticed that I wired this up to do a 5-bit intensity, which relates to 32 different shades. But the indicator portion of this entire circuit was never adjusted to do the 5 bits. It is stuck on 4 bits. So although we haven't quite tested the driver yet, so long as it works, we should get 32 shades of intensity out of our high-powered LEDs, but the indicator portion still thinks it's on 4-bit. So that's why it cycles through again. This is going to take some thinking to figure out how I'm going to solve this problem. So I made a little boo-boo on the driver too. The connector holes were too small. Well, not all the connector holes, just two of them. So take a look. I managed to get these connectors in perfectly fine, but I could not get those two connectors. The connector that I'm using, I need it to pass through the driver, so theoretically we can stack the drivers. And these kind of connectors will allow me to do that. But of course, I screwed up the hole size. Look at the schematic. See, this was the schematic I sent in for production, and you can clearly see the large pads I used for these connectors. And I should have used the same size pad for these two connectors. These are the two power connectors, but they're clearly smaller. So I won't be able to make those connections. I did manage to salvage it though. I used two straight pieces of wire and soldered them into the connectors just to kind of fake a connector for now. It's not going to be stackable, but it will allow us to test it. So to test this, we'll take our driver, attach it to our controller, I'll add some power and ground, and then we'll connect up our LEDs. Moment of truth as we power this up. Let's see if it works. Brilliant. So we had a few issues. They're pretty minor. We can fix it. Mostly, this was a success. Oh, I'm so excited. We'll see you next time as we continue our journey.